There are galaxies out there that should not exist. By every rule we have, they are far too big and far too grown up to be sitting this close to the beginning of time. And yet, there they are, caught in some of the deepest images we have ever taken, glowing back at us from the far edge of what you can see. You are looking back more than 13 billion years, almost to the beginning. And staring back at you are objects that, by our best science, simply ran out of time to form. So which is it? Is our story of how the universe grew up simply wrong? Or is something in this ancient light fooling us? Tonight, you find out. The proof comes from the James Webb Space Telescope. A golden mirror the size of a room, floating 1,000,000 miles from Earth, built to catch the faint, stretched out light of the universe's first few 100 million years. It took 30 years to build, and within its very first weeks of looking, it found the thing no one was ready for. And when it finally opened its eye, the first deep image stopped people cold. In a patch of sky the size of a grain of sand, held at arm's length, there were thousands of galaxies, some of them among the oldest humanity had ever seen. It is hard to even hold this in your head. Every one of those faint specks is a galaxy with billions of stars of its own, and Webb was built to reach the very faintest of them in the very first. And here's what makes those pictures dangerous. Looking far into space means looking back in time, because light takes time to travel. Webb was not just seeing far, it was seeing almost the very beginning. And there is a fingerprint. The farther light travels through an expanding universe, the more it gets stretched toward red. Astronomers call it redshift. A high redshift means old and far and early. Not long after, a team led by the astronomer Ivo Labe pointed Webb at a tiny patch of sky and found 6 of them. 6 galaxies from just 500 to 700 million years after the Big Bang. And they were huge. Each one seemed to hold as many stars as our entire Milky Way, but packed into a space 30 times smaller. Picture a grown adult, all of their mass, squeezed into a body 6 centimeters tall. The comparison only goes so far, since a galaxy is mostly empty space, not a solid body. But the core problem is real. Too much mass gathered far too early. And it was not just their size. They looked settled, mature, full of old, red stars, as if they had already lived a long life in a universe that had barely begun one. The team started calling them something that stuck: universe breakers. One of the researchers, Joel Leja, put it plainly. This upends what many of us thought was settled science. And so far, he said, these objects were living up to their name. For a few weeks, it was everywhere. Headlines said the universe was broken, that Webb had shattered the Big Bang, and you can see why that story spread so fast. But here is what actually made astronomers uneasy. It was not that these galaxies were strange. It was that, by the rules, they should not have had the time. In our best model of the cosmos, galaxies grow slowly. Gravity gathers gas. Gas forms stars. And a galaxy the size of the Milky Way takes billions of years, not millions, to assemble. There is also a budget. The universe holds only so much ordinary matter, and star making is surprisingly wasteful. Usually, only about 1/10 of a galaxy's gas ever becomes stars. Hold on to that number. 1/10. Because these early galaxies looked like they had ignored it completely. Here is why. The first big stars to form are violent. They blaze, and then they explode as supernovae, and those explosions blow the surrounding gas away, before it can collapse into even more stars. To build these giants that early, a galaxy would have had to turn nearly all of its gas into stars, almost at once, wasting nothing at all. And nothing we had ever watched could do that. It would be a little like watching an entire city build itself, fully, in a single afternoon. Not literally, of course. But that is roughly how fast this would have had to happen. And here is the strange part. These galaxies did not look rushed at all. They looked calm, finished, as if they had all the time in the world, in a universe that had given them almost none. So for a few months, it really did look like the model of the universe was in trouble. So sit with that. The light is real. The galaxies are there. And the rules say they cannot be. Which means one of two things has to give. The rules or the way we are reading the light. It is a strange feeling, isn't it? To look at something ancient and true and realize you might not understand it at all. This is the part I keep coming back to. Because science did not panic. It did something quieter and far more powerful. It doubted itself. Carefully. Those first measurements were guesses from color, a technique called photometry. You take a few pictures through different filters, and from the balance of light, you estimate how far away something is. Useful, but easy to fool. So astronomers went back with a tool that is much harder to fool. Spectroscopy. It splits a galaxy's light into a full rainbow, hundreds of shades where a single color used to be. And in that rainbow are lines, bright and dark bands, like a barcode, printed by specific atoms. The comparison is loose, but that pattern pins down distance and chemistry in a way a blurry color never can. So they aimed it at the impossible galaxies, one by one. And the rainbows began telling a different story. One record breaker, thought to sit impossibly early, turned out to be an imposter. It was not at the dawn of time at all. It was a dusty galaxy much closer to us, its warm glow mimicking the colors of something far more distant. Dust was part of the trick. Thick dust reddens light, and reddened light can look almost exactly like the glow of a much older, much more distant galaxy. Fool the color, and you fool the distance. A few of the earliest records slipped quietly closer to home. Not to the dawn of time, but to a calmer, more ordinary place in cosmic history. The illusion was good, but it was still an illusion, and it was only the first crack in the mystery. Because the biggest surprise was not about distance at all. It was about what these objects actually were. Many of the impossible galaxies were not galaxies full of stars at all. At the heart of each one sat something else, a supermassive black hole, feeding. A furnace of falling gas, so bright that it wore the disguise of 1 billion stars. Astronomers gave them a nickname, little red dots. And once they started looking, they were everywhere. A whole population of them, tiny, red, and far too bright for their size. Something no one had predicted. And here is how they caught it. In the spectrum, the light showed enormously broad emission lines. That is the signature of gas whipping around something small and heavy at thousands of kilometers a second. Stars in a galaxy simply cannot fake that. A few were stranger still. Even a normal black hole could not fully explain them. So astronomers floated an even wilder idea. A black hole wrapped in gas so thick that it glows like a star. A black hole star. And that one, for now, is still just a hypothesis. But for the little red dots, the conclusion was clear. When astronomers finally subtracted the black hole's glare, the estimated masses did not just shrink, they fell. By 10, even 100 times. And there was a gift hidden in the disappointment. If these really are early black holes, feeding hard, then Webb had stumbled onto something else entirely. A front row seat to how the universe's giant black holes first switched on. Object after object that had looked impossible was moved back into the ordinary. Not a broken universe, after all. A misread one. And with that, the crisis quietly dissolved. The astronomer Stephen Finkelstein put it about as plainly as anyone can. "There is no crisis," he said, in the standard model of cosmology. The headlines had simply been running ahead of the data. The real surprise was gentler, and in a way, far stranger. It was not that our physics was wrong. It was that the infant universe was simply better at its job than anyone had dared to expect. Quicker to gather its gas, quicker to light its first stars, and quicker, much quicker, to grow its first giant black holes. How, exactly? That part is still open. Maybe the early universe let stars form in bursts, too fast for any explosion to stop. Maybe it just favored bigger, brighter stars. Nobody knows yet. And honestly, that is the fun of it. And the real mystery, the one that is still alive, is no longer whether the model holds. It is exactly how the first stars and the first black holes grew up so fast, so early. That question is still open. And Webb, even as you watch this, is still chasing it. But strip away the illusions, and what is left standing is real. And it is far stranger and far more beautiful than the mistake that hid it. Its name is a mouthful. JWST 14-0. It is one of the most distant things humanity has ever confirmed. You are seeing it as it was, 290 million years after the Big Bang. Let that land. The light that Webb is gathering tonight, the light you are looking at right now, left that galaxy before the Earth existed, before the Sun, when the universe itself was barely beginning. 13.5 billion years of travel, ending on a mirror built by human hands. One ancient photon, crossing almost the entire history of the universe, just to become a single point of light on a screen. And it is not alone. Webb keeps adding to this hidden dawn, galaxy by galaxy, sharper every year. We are among the first humans who can see this far, and this early. For almost all of human history, this light was already here, and no eye on Earth could catch it, until now. And using a separate observatory, a giant radio array in Chile called ALMA, astronomers found something inside that galaxy that no one expected so soon. Oxygen. Which means that even then, whole generations of massive stars had already been born and burned and died. Think about what that means. The very first stars had to die so that everything after them could exist. Their deaths forged the atoms of planets and oceans, and eventually of us. Destruction as a kind of creation. The calcium in your bones, the iron in your blood. That story starts here in light this old. For a while, it looked like the universe had broken its own rules. It had not. We had just misread the light, and then, patiently, we corrected ourselves. Maybe that is the quietest kind of wonder there is. Not a universe that shocks you, but one that keeps inviting you to look again, and to get it a little less wrong each time. Somewhere out there, the next story is already unfolding. There is another impossible object out there, one Webb is still trying to explain. It is the next video in this series, and you can watch it right now.